Right now, you're staring at a galaxy containing 1 trillion stars, hurtling toward us at 250,000 ampere. That galaxy is Andromeda, a galactic titan that dwarfs everything we believed possible. It stretches across 220,000 light-years of space, making our own Milky Way look small by comparison. The immense cosmic forces shaping Andromeda have remained largely hidden from human eyes until now. Yet tonight, we embark on a journey to unveil the true scale of Andromeda, to experience its blazing core, its invisible dark matter halo, its star-forming regions, and ancient globular clusters. If you're ready to explore a galaxy more magnificent than you ever imagined, hit that like button and subscribe. This journey into Andromeda's heart begins now. Far above the night sky, there's a faint smudge of light marking the truth that has always been with us. This elusive blur in the sky is Andromeda, our nearest galactic neighbor. For centuries, humanity has gazed up in awe at this cosmic beacon, trying to understand its nature. At first glance, Andromeda hardly seems worth noticing. If you step outside on a dark autumn evening, away from the glow of city lights, you might mistake it for a tiny patch of cloud. It doesn't twinkle like the stars, nor blaze like a planet. It simply lingers there, a ghostly glow painting the heavens. But, as humanity would soon discover, this faint blur holds more stars than our entire galaxy. What appears to be something small to the naked eye is, in truth, a sprawling cosmic giant. It wasn't until the age of telescopes that Andromeda revealed its monumental size. Early astronomers saw it through glass lenses, initially calling it a nebula, a term meaning cloud. To them, it was a strange patch of gas within our own galaxy. The idea that Andromeda was an entirely separate galaxy seemed unthinkable. Yet, the truth was already written in the faint light that had traveled across the vast void for millions of years to reach us. Imagine this: when the photons you're seeing tonight first set out, continents were vastly different. Ice ages rose and fell, and entire species evolved, thrived, and vanished long before humanity ever walked the earth. This light, which now graces your eyes, began its journey millions of years ago, at a time when human ancestors were not yet a thought in the evolutionary timeline. This journey across space is a story in itself, one that speaks of time, of change, and of cosmic scale. When scientists first measured Andromeda's distance, they were shocked. That smudge, once thought to be a simple nebula, was 2.5 million light-years away. This discovery shattered the idea that the Milky Way was the entire universe. Instead, we learned that our galaxy is just one among billions of others, drifting in an ocean of stars. Andromeda stands as a stark reminder of the true scale of the cosmos, forcing us to reconsider how we see our place in the universe. But let's pause and go deeper into the heart of this mystery. When we first gazed upon Andromeda, ancient civilizations had already noticed its presence in the night sky. To them, it was something more than a distant glow. It was a divine presence, a heavenly sign, something to be revered and feared. Ancient Greek storytellers saw Andromeda as part of their mythology, imagining her as the chained princess, forever bound to a rock as a sacrifice to a monstrous sea creature. They could never have known that this delicate blur was not just a myth, not just a star or a cloud, but the gateway to a galaxy containing more stars than we can fathom. As centuries passed, astronomers peered into the night sky, unable to grasp the true scale of what lay before them. Andromeda was mistakenly called a nebula by early stargazers, who assumed it was a distant cluster of gas within the Milky Way. In their time, it seemed unthinkable that there could be other galaxies so far beyond our own. Their perspective of the universe was confined to the stars and nebulae within our galaxy, and anything beyond that was pure imagination. Andromeda, in all its unimaginable vastness, was yet to reveal itself fully. But now we know better. The light we see from Andromeda tonight began its long journey when the world was ruled by creatures that are now long extinct. This light, soft as it seems, carries with it the essence of an ancient past, a past so distant that it feels like we're looking through time itself. It's not just the light of a distant galaxy, it's the light of history, frozen in time and space, just waiting for us to witness it. Andromeda is a reminder of perspective. What seems small, this faint blur, is, in reality, a galaxy of mind-boggling scale and a testament to the infinite wonders of the universe. So, when you look up at Andromeda tonight, know that you're seeing more than just a celestial object. You're witnessing time itself, stretching out into the unfathomable past, reaching back millions of years. And as you do, consider that the light you see tonight will eventually fade into the distant future, only to be replaced by new generations of stars. The universe moves. It is dynamic, alive, and constantly unfolding. And we, like everything else, are merely a brief part of its endless evolution. As we venture deeper into the heart of Andromeda, the story begins to unravel in ways that are both mind-boggling and humbling. The galaxy, stretching across 200,000 light-years, is not just an expanse of stars, it's a cosmic furnace, a place where creation and destruction happen on a scale far beyond our human understanding. Andromeda's stars are not all the same. In fact, the galaxy contains a remarkable diversity of stellar populations, from ancient red dwarfs to massive blue giants, each one with a story to tell. Some of these stars are ancient survivors, shining long before our sun ever took form, while others are still born in star nurseries, glowing with fierce brilliance. But even more remarkable are the streams of stars, vast rivers that tell the story of Andromeda's past. These rivers are the remnants of galaxies that Andromeda has consumed in the cosmic feast that has shaped it. Over billions of years, smaller galaxies have ventured too close, only to be torn apart and absorbed by the mighty gravitational force of Andromeda. These stellar streams, once separate galaxies, are now interwoven into the very fabric of Andromeda's immense mass. Astronomers have discovered more than a dozen of these stellar streams, stretching across Andromeda's outskirts. These glowing ribbons of light are not mere accidents, they are fossils, preserving the evidence of violent galactic collisions that have shaped the galaxy. Some of these streams are the remnants of smaller galaxies. Others are the leftovers of lesser systems Andromeda has swallowed. But each star within these streams was once part of a galaxy of its own, an independent system until Andromeda's gravity took it in. Now, scattered across Andromeda's halo, these ancient stars remain locked in orbit, forever changed. The galaxy's dark matter halo, which extends far beyond the visible stars, binds them together. It's an invisible structure that is as crucial to the galaxy's formation as its glowing disk. And this invisible force, though it can't be seen directly, is one of the most massive forces in the universe. Without it, Andromeda and every galaxy would not have the structure we recognize. It is this dark matter halo that pulls the stars into their orbits and guides their motions across the void of space. At the very center of Andromeda's spiral arms lies the beating heart of the galaxy, a supermassive black hole that dwarfs even our own Sagittarius Eos, the black hole at the heart of the Milky Way. This black hole is over 100 million times the mass of the Sun, a force so powerful that it shapes not just the stars around it, but the entire galaxy itself. From a distance, Andromeda's core might seem like a calm, glowing orb, a gentle beacon in the dark sky. But this serenity is deceptive. Inside that glow lies an environment so extreme that not even light can escape from it once it crosses the event horizon. The core is a region of chaos. Gas clouds spiral in, pulled by the black hole's unrelenting gravity, getting heated up to temperatures that emit X-rays. Some stars that venture too close to the black hole are torn apart in tidal disruption events, where the immense gravitational forces stretch them into long, thin strands before they're shredded into oblivion. Yet, this black hole is more than just a devourer. It is a cosmic architect. Without it, the inner stars of Andromeda would be lost, drifting aimlessly across the galaxy. It is the black hole's gravitational influence that keeps the galaxy's inner stars in orderly orbits, ensuring that Andromeda doesn't fall into chaos. So, in a sense, this black hole is both a destroyer and a sustainer, balancing the forces of life and death across the galaxy. Occasionally, the black hole awakens, swallowing vast quantities of matter and releasing jets of high-energy radiation that stretch out for thousands of light years. These eruptions are brief, but they leave behind scars in the surrounding gas and stars, transforming the galaxy and giving us a glimpse into the power of this invisible force. As we move outward from the black hole, the galaxy's spiral arms beckon. These arms are not solid structures. Rather, they are patterns in motion, regions where matter accumulates, forming new stars and planets. To the human eye, they appear as elegant swirls of light, but up close, they are alive with the chaos of creation and destruction. In the spiral arms, massive molecular clouds collapse under their own gravity, sparking the birth of new stars. Some of these stars are so massive they burn through their fuel in a few million years, exploding in supernovas and sending shockwaves through the galaxy, triggering new cycles of star formation. The birth of stars in these arms is not just a spectacle, it's the foundation of galactic life, shaping the structure of the galaxy itself. As gas and dust flow through the spiral arms, they compress and ignite, creating new suns that flood the surrounding regions with light and energy. These newborn stars can be incredibly massive and hot, shining in a fierce blue-white glow. Their short lives lead to supernovas, seeding the galaxy with heavy elements like oxygen, carbon, and iron, the very building blocks of life. But even within these active arms, Andromeda is shrouded in mystery. Enormous clouds of interstellar dust weave through the galaxy's spiral structure, hiding its true form from view. These clouds are both a challenge and a treasure for astronomers, as they obscure our vision but also serve as stellar nurseries, places where new stars are born from the cosmic shadows. Through the interstellar dust, the galaxy's structure becomes apparent in infrared and radio telescopes, which reveal hidden regions where new stars and planetary systems are forming. These dust clouds are not empty, they are the raw material of creation, gathering over millions of years to give rise to new suns. These clouds serve as the building blocks of Andromeda's future, quietly shaping the galaxy from within. The dust is both a veil and a promise. It obscures the full scale of Andromeda, making it seem smaller and more fragmented than it truly is. But at the same time, it is the canvas upon which stars are painted, where the seeds of new worlds are sown. It is within these dark veils that the future of Andromeda is being created, hidden from view, but shaping the galaxy's destiny. For decades, astronomers struggled to measure Andromeda's full scale. The galaxy seemed much smaller than it truly was. But as technology improved, we began to uncover the truth. Andromeda's true boundaries extend twice as far as we had once believed. While the visible galaxy, its bright core and spiral arms, might stretch 100,000 light years, its full size, when you account for its stellar halo and the presence of dark matter, stretches much farther. This revelation changed not just our understanding of Andromeda, but our understanding of galaxies as a whole. Galaxies do not have sharp, defined edges like planets. Instead, their influence fades gradually, their stars drifting into halos, and their gas spreading into clouds. And Andromeda's influence stretches far beyond what we had once thought, blending into the larger cosmic web that connects galaxies across the universe. As we continue our journey through Andromeda, the magnitude of its complexity becomes ever more apparent. The more we discover, the more it seems like a living, breathing entity. Its stars and galaxies constantly interacting, colliding, and reshaping its very structure. Andromeda, like all galaxies, is in a constant state of flux, growing, evolving, and consuming smaller systems, yet it carries a history that spans billions of years. This galactic giant has been in the process of devouring its smaller neighbors for eons, and its growth is still ongoing. The most compelling evidence of this process is found in the vast streams of stars that wrap around Andromeda's outskirts. These stellar rivers, stretching across hundreds of thousands of light years, are the remnants of smaller galaxies that Andromeda has consumed over the course of its long existence. Each of these streams carries the signatures of galaxies swallowed long ago, their stars forever bound to Andromeda by its immense gravitational pull. This process of galactic cannibalism is not unique to Andromeda. It's a fundamental mechanism through which galaxies like ours grow. But, in Andromeda's case, the scale is particularly staggering. Its gravitational reach has absorbed entire galaxies, ripping them apart and scattering their stars across its halo. The larger the galaxy, the greater its gravitational pull, and Andromeda is one of the largest galaxies in the local group. Its gravitational influence is so immense that it continues to pull in smaller galaxies from its surroundings, leading to a continuous cycle of accretion. The presence of these stellar streams is not merely a curiosity. They provide invaluable insight into Andromeda's past. Each stream is like a record of a cosmic event that occurred billions of years ago, a cosmic fossil that tells the story of how Andromeda grew into the vast galaxy it is today. Some of these stellar streams are ancient, stretching back to the early days of Andromeda's formation, while others are much more recent, created by galaxies absorbed in the last few billion years. The sheer number of these streams is astounding. There are at least 20 known stellar streams orbiting Andromeda, each one a reminder of a different galactic encounter, some of which happened billions of years ago. These streams form a vast, intricate web around the galaxy, interwoven with Andromeda's dark matter halo. The dark matter halo, though invisible to the naked eye, plays an essential role in shaping the galaxy. It is the silent force that governs Andromeda's gravity and controls the motion of its stars, gas, and other matter. Interestingly, the discovery of these stellar streams has had a profound impact on our understanding of dark matter. These streams are the first tangible evidence we have that dark matter exists. The stars in the streams are moving faster than they should be, based on the amount of visible matter in the galaxy. This suggests the presence of unseen mass, which we now know is dark matter. Andromeda's dark matter halo extends far beyond the visible galaxy, reaching out to nearly 2 million light-years, far beyond the 100,000 light-years of visible matter. This halo, invisible to our instruments, is by far the most massive component of the galaxy, outweighing the visible stars and gas. The discovery of dark matter in Andromeda's halo was a game-changer for scientists. It confirmed what had long been suspected, that the universe is filled with invisible mass that cannot be detected through traditional means. Dark matter is not composed of the familiar particles we encounter in our everyday lives, and it doesn't emit light or energy. It interacts with ordinary matter only through gravity, but it is the force of gravity that holds galaxies like Andromeda together. Without dark matter, galaxies would not have the mass necessary to maintain their structure, and they would fly apart over time. The study of Andromeda's dark matter halo has provided astronomers with critical clues about the nature of the universe itself. It suggests that dark matter is not only common but essential for the formation and stability of galaxies. Without dark matter, the universe would be a vastly different place, with galaxies unable to form or survive for billions of years. But the story of Andromeda is not just about stars and dark matter. It's also about the extraordinary events that occur within its boundaries. The core of Andromeda, like the core of every large galaxy, is home to a supermassive black hole. This black hole, weighing in at over 100 million solar masses, is one of the most powerful forces in the galaxy. It is the anchor around which the entire galaxy structure is organized, and its gravity dominates the inner regions of Andromeda. The supermassive black hole at Andromeda's center is not a quiet, dormant object. It is active and occasionally erupts in bursts of energy, producing jets of radiation that can stretch for thousands of light years. These eruptions are the result of the black hole swallowing large amounts of matter, which heats up as it spirals into the event horizon. When this happens, the black hole emits intense radiation, including X-rays and gamma rays, which astronomers can detect from Earth. The behavior of Andromeda's central black hole is similar to that of other supermassive black holes found at the centers of most galaxies. These black holes are thought to have formed early in the universe's history, and they have been growing ever since by accreting gas, stars, and even entire galaxies. They are the largest and most powerful black holes in the universe, and their influence extends across vast distances. What makes Andromeda's black hole particularly interesting is that it appears to be in a relatively quiet phase. It is not currently consuming large amounts of matter, and its jets are not as active as they once were. However, scientists believe that this could change in the future. In fact, some theorize that Andromeda's black hole will eventually enter a more active phase, triggering a burst of energy that will reshape the galaxy's core and surrounding regions. Despite the immense gravitational forces at play in Andromeda's core, the stars that orbit the black hole do so in a remarkably stable manner. These stars form a tight-knit group, moving in predictable orbits around the black hole. Their motions are influenced by the black hole's gravity, and by studying these stars, astronomers can learn more about the properties of the black hole itself. As we move farther from the core, we begin to see the galaxy's spiral arms, regions of intense star formation and complex gas dynamics. These spiral arms are the heart of Andromeda's star-making activity. Gas clouds, rich in hydrogen, collapse under their own gravity, triggering the formation of new stars. Some of these stars are born in clusters, surrounded by nebulae and gas clouds. These young stars shine with intense blue-white light, a sign of their massive size and short lifespans. But not all stars in Andromeda's spiral arms are young. The galaxy's stellar population is diverse, with older, redder stars scattered throughout the galaxy. These stars are relics from an earlier era, survivors from Andromeda's past. Many of these stars belong to the galaxy's bulge, the dense central region that contains the oldest stars in the galaxy. The bulge is dominated by stars that have been around for billions of years, and they provide a glimpse into the galaxy's early history. As we look deeper into Andromeda's spiral arms, we find even more evidence of the galaxy's past. Stellar nurseries, regions of dense gas and dust, are scattered throughout the galaxy. These nurseries are the birthplaces of new stars, and they are responsible for much of the galaxy's ongoing star formation. Over time, these nurseries will give birth to new generations of stars, which will continue to shape Andromeda's future. But there is also a dark side to this process. Not all stars survive for billions of years. Some stars burn through their fuel too quickly, ending their lives in catastrophic explosions known as supernovas. These violent events release enormous amounts of energy, and they can leave behind remnants like neutron stars or black holes. The gas and dust expelled during a supernova can also trigger the formation of new stars, continuing the cycle of creation and destruction that drives the evolution of galaxies. Through these processes, Andromeda continues to evolve. It is a galaxy that has been shaped by cosmic collisions, by the creation and death of stars, and by the slow, relentless forces of gravity. It is a reminder of the complexity of the universe, of how galaxies grow and change over time. And as we continue to study Andromeda, we gain insight into the forces that have shaped our own galaxy, the Milky Way, and the fate that awaits us as our two galaxies slowly move toward a future merger. As we venture farther from Andromeda's core, we see the galaxy's outer regions, where gas and dust form the building blocks of new stars. These regions, known as stellar nurseries, are where gas clouds collapse under gravity to form new suns, continuously feeding the galaxy's growth. These clouds are not empty space, but cosmic factories, constantly creating the next generation of stars and planets. The sheer rate of star formation in these regions is astounding. For every moment that passes, new stars are born, adding to Andromeda's growing population. Alongside this creation, destruction is also at work. Supernovae, the explosive deaths of massive stars, are common in Andromeda. These violent explosions briefly outshine the galaxy itself and scatter heavy elements that become the raw material for future stars and planets. After the explosion, the remnants either form neutron stars, where matter is crushed into an incredibly small space, or black holes, where gravity is so strong that not even light can escape. Despite these violent events, Andromeda's structure is characterized by remarkable symmetry. Its spiral arms, where most of its stars are born, are not solid objects, but patterns formed by the flow of gas and matter. These arms act like cosmic highways, constantly adding new stars to the galaxy. Though the galaxy is constantly in motion, these arms remain a defining feature of Andromeda, revealing both creation and destruction in their graceful arcs. The stars in Andromeda's core, some of the oldest in the galaxy, continue to shine brightly. They have survived the galaxy's tumultuous history and remain anchored by the supermassive black hole at the center, which holds Andromeda together, ensuring the stars orbit in stable paths. Without this invisible anchor, the galaxy would be in chaos. The black hole's gravity provides stability, keeping Andromeda intact even as its outer regions evolve. As we move further outward from the core, we encounter dwarf galaxies that orbit Andromeda. These smaller galaxies are slowly being pulled into Andromeda's gravitational field, where they will eventually be absorbed. This process, known as galactic cannibalism, has been a key factor in Andromeda's growth. Over billions of years, it has consumed smaller galaxies, adding their stars and gas to its own. Some of these galaxies have already been completely absorbed, their stars now part of Andromeda's vast population. This ongoing process of galactic cannibalism is a form of cosmic recycling. The smaller galaxies are not destroyed, but integrated into the larger galaxy, their matter repurposed for the formation of new stars and planets. It's through this process that Andromeda has grown from a modest spiral into the enormous galaxy we see today. And yet, this is not a unique characteristic of Andromeda. The Milky Way, too, is in the process of absorbing smaller galaxies, such as the Sagittarius dwarf galaxy. Beyond Andromeda, the galaxy is part of the cosmic web, a vast network of galaxies bound together by gravity. The local group, which includes Andromeda, the Milky Way, and several smaller galaxies, is a small part of this larger structure. Andromeda and the Milky Way are already interacting, their halos overlapping as they drift closer to one another. In about 4 billion years, they will merge, forming a single, larger galaxy. This future merger is a reminder of the impermanence of galaxies, as they grow and evolve through cosmic events like this. This merger will not be a violent crash, but a slow, gradual process, with the two galaxies passing through one another in a dance orchestrated by gravity. The collision will trigger bursts of star formation as gas clouds collide, and for a time, both galaxies will shine brighter than ever before. From Earth, if we are still around, the night sky will be transformed. Andromeda, once a faint smudge, will fill the sky, its spiral arms blending with the Milky Way's, creating an awe-inspiring spectacle. The merger will eventually lead to the formation of a new galaxy, one much larger than either the Milky Way or Andromeda. This new galaxy, known as Milkomeda, will be an elliptical galaxy with no distinct spiral arms, but a vast, smooth structure that holds more stars than either of its parents. The process will take billions of years, but the legacy of this cosmic event will live on. The merger of Andromeda and the Milky Way will create a new chapter in the history of the universe. As we look at Andromeda from Earth, we see not just a distant galaxy, but a reflection of our own future. The same processes that shape Andromeda are shaping the Milky Way, and one day the two will merge, creating a galaxy that will be home to new stars, planets, and potentially life. Andromeda is not just a neighbor in the cosmos, it is a mirror of our galaxy's future, a reminder that the universe is constantly changing, growing, and evolving.